Hello students, this is Dr. Diaz again, and we're talking a little bit about volume problems that you're gonna love this. This is the easiest part of a stoichiometry when we start with volume and we ask you the final volume. So, and why this is the easiest part, is this easiest thing to do it, is because Gay-Lussac discovered that volumes of gases under similar conditions combining in small whole number ratios. This is the law of combining volumes. Avogadro hypothesis asserted that under identical conditions of temperature and pressure, equal volumes of different gases contain an equal number of gas particles. As in atypical conditions, and you need to remember this, 1 mole of any gas will occupy precisely 22.4 liters. So let's simplify this. So when we involve gas, if you have 1 mole of nitrogen, 1 mole of oxygen, 2 moles of oxygen, I'm gonna have 1 mole on a volume of nitrogen, 2 volumes of oxygen, as well 2 moles of NO2, we have 2 volumes of NO2, okay? And here, for example, we have hydrogen and chlorine forming hydrochloric acid. So I have 10 milliliters of hydrogen, will react to 10 milliliters of Cl2 or chlorine to produce 20 milliliters of HCl. The ratio of volume is 1:2. What is this? This is the coefficients that you see here. So you don't see numbers, it's 1, 1, 1, 2. This will help you to find the final volume when you have a different number of moles. If it tells you, oh, we have 42 moles of hydrogen, I know without any math that I'm going to produce 84 moles of hydrochloric acid. But we need to put this on paper to understand better. So let's go to an example. So before we go to example, let's remember volume stoichiometry is the easiest one problem. And everything is reduced in just one single step. This is the really good thing about the volume problems. So we convert the given volume into the unknown volume using the mole ratio that actually is the volume ratio, as we saw. So the equivalent over here, okay? So from the balance came equations. So let's go to this example. How many liters of oxygen reacts with 37.5 liters of sulfur dioxide in the production of sulfur trioxide gas? So we have 2 moles over here, 1 mole over here, 2 moles. So I have 2 per 1 per 2, right? So if I know this, if I have 1 liter of O2, this O2 will react with 2 liters of SO2 because they are equivalent. So if I don't know how many liters of O2, if I have 37.5 liters of SO2, the only thing that you need to know is the mole ratio or volume ratio. So 1 liter of, say over here, oxygen, and we have 2 liters of SO2. Simple thing, okay? So the same thing, so the only thing that I did here is 37.5 times 1 divided by 2, exactly what I have here, right? How many SO3 are produced? They say, see, we have a 2 for 2. I know that if you have 4, I'm going to have 4 SO3. If you have 8 SO2, I'm going to have 8 SO3. So if I have 37.5 liters of SO2, I'm going to have produced 37.5 liters of SO3. So, but let's put this on numbers. So this is the mole ratio or volume ratio of the equation, right? So I have 2 liters, because I have 2 over here, of SO3, sorry, SO3 is over here, and 2 liters of SO2 that is over here. So cut, because 2 divided by 2 is 1, so what I have is 37.5 liters of SO3. So this is how simple is the work with the volume to volume problems in stoichiometry. Okay, so next video, we're gonna practice some problems, stoichiometry problem. Okay, so that's it, that's all.